I'm going to show you how to solve an equation that has parentheses, just like we have here. And there's only one extra step you're going to be using, with regard to the video when I showed you where we did two-step equations. Well, this is similar, except there's one extra step. And there's actually two different methods you can use to solve these types of problems. So again, if you see a problem like this, where you have parentheses, a number on the outside multiplied with that, equal to another number. So if it looks like this, I'm going to show you two different methods to use. So first thing I'm going to do is I'm going to write down the problem. And again, this is going to be, let's call this one method 1. So method 1 is going to be, let me write it down, 4y minus 7 equals 66. The first thing that I'm going to look for is this. I noticed that here we have, if you see a number next to parentheses, there's nothing in between it. Automatically that means multiplication. So that means we're multiplying. And the first thing I'm going to look for, if possible, is can I divide by this number here? And in this case, I'm going to divide by 2. If I can divide this number by 2, and notice that, again, that's the opposite of multiplication, is division. You got to balance the equation and do the same thing to the other side. That's the first thing I check for. And in this case, I could see that I could divide by 2 to both sides, because when I divide this out, 2 divided by 2, that's just going to reduce to 1 and 1. And over here, 66 divided by 2 is actually equal to 33. So it works out fine. And you want to use this method if you're able to divide it such that this doesn't stay at turn into a decimal, or you get a fraction. Because you could do it that way, but I don't recommend it, because then you have to work with a fraction throughout the whole problem. So if you do end up with a decimal or fraction, that's when I'm going to show you method 2 on how to do method 2. But since we could divide it out, we're going to continue going this way. And what I'm going to do here, this became 1, that became 1. So essentially, I don't usually do this work here, but I'm going to show you just so you can have it as a reference. You can see how it simplifies. So you can see here, this became 1 and 1, right? 2 divided by 2 become 1 over 1. 1 times this, if you were to multiply 1, right? Any number, whatever it is, or expression times 1, you're going to get back the same thing. 4y minus 7 divided by 1. So I'm just simplifying the left side. And anytime you divide something by 1, you're going to get back whatever your numerator is. So we get 4y minus 7. Again, we divide by 1, doesn't change anything. So this is what we get. So essentially, what you could do is, once you notice that these numbers, right, cancel out and they reduce to 1 and 1, you could go from this step immediately to this step, because the only thing that's left is the numerator here, 4y minus 7. And on the right side, you can see that we ended up getting 33 when we simplified it. And now you can see we have a two-step equation. We're trying to solve for 1y. And notice that, y is on the left side of the equal sign, right, on this side. And we have two terms, the 4y and the 7. I don't want the 7 here, so I'm going to get rid of that using the additive inverse. Remember, additive inverse means opposite of what's happening here. So this is minus 7. Opposite of a minus, or if you ignore the 4y, that's like a negative 7. The opposite is a positive. So I'm going to put plus 7. That's the opposite. That's the additive inverse. And by additive inverse, as a side note, all that means is this. If you have a number and you add it, you combine it with the opposite, it's going to give you 0. So when we combine these opposites, we know that that's going to cancel out. We're going to get 0 from that. And don't forget, if you add 7 to one side, you got to balance the equation, add 7 to the other side. This is what we call addition property of equality. I added the same amount to both sides. That's important when you're solving equations, because you want to keep the equation balanced. So again, this is how you show your work. Next, we're going to bring down the remaining term on the left side, which is 4y, and simplify this side. 33 plus 7 is 40. And now we have one step left. We don't want 4y, we want 1y. So one thing I noticed, this is 4 times y. And the opposite of multiplying by 4 is to divide by 4. So I'm going to divide by 4 to this side, and to balance the equation, I'm going to divide the other side by 4 as well. This is called division property of equality, because I divided both sides by 4. That's what you need to do. Property of equality helps balance the equation so that whatever is true here in my next equation is still going to be true. And you can see here, 4 divided by 4 is just 1. So we get 1y equals 40 divided by 4, which is 10. And that's my final answer, y equals 10. Again, this is method 1 that I just showed you. And notice that, again, we divided both sides by 2 in the case that we know that we're going to use this method if we're able to divide this out such that we get a whole amount or an integer back. If you end up with a decimal, a fraction, don't use this method. I recommend the second method, which I'll show you now. So what you're going to do first, though, let's say we do divide it and you end up with a decimal or a fraction over here. You don't get back a whole amount or an integer. So what you're going to do is what we call the distributive property first, right? We're going to distribute. Because don't forget, again, this is 2 times. You're multiplying, which means we got to use the distributive property because each of these terms is multiplied by 2. So when I multiply 2 times 4y, I'm going to get 8y there. I'm going to bring down my minus sign. And then 2 times 7 is 14. And then bring down the rest, equals 66. And then next, I'm going to solve for y. So I know that I'm trying to get this term, I isolate this term, which means I got to get rid of this term. So to get rid of this term, we have to use the additive inverse. So in other words, what's the opposite of this number here? So the opposite of a negative, so if I ignore this, that's like saying negative 14. The opposite of a negative is a positive. So I'm going to put plus 14 here. And I have to balance the equation. So whatever I do to this side, I have to do the same thing to the other side. And this is called the addition property of equality because I added the same amount to both sides to balance the equation. And now I'll bring down my equal sign, and I'm going to simplify. Again, this is the additive inverse. When you combine opposites, they cancel each other out. That's 0. And we're left with the term 8y. And then here, when we add this up, we're going to get a total of 80. And then similar to the last problem, we have 8 times y here. Opposite of multiplying by 8 is to divide by 8. And I'm going to balance the equation by dividing the other side by 8 as well. Again, this is called division property of equality because we divided both sides by the same amount. And that's what we need to do to balance the equation. Bring down my equal sign. 8 divided by 8 is 1, so we're left with 1y. 80 divided by 8 is 10. And you can see we got the same answer as before. And when you compare method 2 to method 1, you can see that method 1, it did have more steps, but like I said before, that I usually don't show the work that you see in, where is it at? This area here. I just did that for notes purposes, so you can see how I got from here to here, just in case you needed to see that. All right, but basically we had 1, 2, 3, 4 steps essentially. Here we had, 1, 2, 3, 4. So about the same thing comes out to be. So again, method 1, I recommend if you're able to divide both sides by this amount and you don't get a decimal, then, use this method. If you do end up with a decimal or a fraction, go with the second method where you distribute first. And then, you might end up with a fraction in the end, but it just makes it a little bit easier throughout the problem to do it without the fraction in the beginning. So save that part to the end.